My name is Ryan Johnson, and I'm from CryptoWire, and I collaborated with Angelo Stavro and Azzedine Benamur for this research. The title of today's talk is All Your SMS and Contacts Belong to ADUPS and Others. So this is when the issue became public. We noticed that the #1 selling unlocked smartphone on Amazon at the time was obtaining your text messages, call log, location, installed apps, unique device identifiers, and sending them to a server in China. So since then, they've scaled back the PII exfiltration in some devices, but in other devices, it's actually gotten a little bit more aggressive, and the issue is still ongoing. And these applications were pre-installed in the device, which you weren't able to disable, and it was done without any user consent or awareness. So people spend a lot of time looking at external threats, but there can be internal threats that are on the device, so that come pre-installed. And anytime you have an Android device, there's some pre-installed apps. They could be framework apps or just bloatware. And these applications can be malicious, so actively trying to harm you, or insecure, which could be leveraged by a local or remote actor to also try and harm you. So today we're going to talk about ADUPS, as well as two other applications which are insecure. They're for debugging and development purposes. So ADUPS is a third-party firmware update provider. So if some OEM doesn't have the expertise or desire to perform their own firmware updates, they will rely on a company like ADUPS. So ADUPS has a set of apps that are present on the device. I've provided the package names up there. And a package name is a unique application ID. There can't be two package names or two applications with the same package name on the device. Of the package names up there, the ones that are in bold execute is the system user, and the system user is a very powerful user which has special privileges on the device. So with ADUPS, if you bought a phone, it would just be running in the background, and the exfiltration would occur without any consent or awareness. It was just happening in the background. So from ADUPS's website, they were claiming that they had presence on 700 million devices. And here's a screenshot from their website of the partners that they have. And since it became public that they were getting user PII, they took down this from their website. So looking at their track record, there's been various issues in the past few years. Back in 2015, somebody on XDA developers was claiming that they were remotely uninstalling unwanted applications, which certainly with the capabilities we've seen, they're able to do this. I'm not sure what applications they were installing, but I don't think it was just the latest version of Candy Crush. And some researchers discovered some vulnerabilities, the bottom two bullets. And if you go to their website, they actually have proof of concept code. We also found a way to get command execution as a system user locally. And this, they just had an exported component which any application co-located on the device could send a message to it, which in Android is an intent. And it would execute the command as a system user. So on their website, we got a screenshot of it. They call us a third-party security firm on the English version of their website, and they also have a Chinese version of their website, so we thought maybe they'd give us a shout out. But I don't know if this is a diss or just bad Google Translate, but they refer to us as Buzz Lightyear Security Lab. So we first noticed the exfiltration on the Blue R1 HD device. And this device at the time was the #1 selling unlocked smartphone on Amazon. And if you go there, I believe currently it's still the #1 selling unlocked smartphone on Amazon. So Blue was using ADUPS at the time, and they're still using ADUPS. And at least on Blue devices, the PII exfiltration has been scaled back, but some of it is still there, which I will talk about in a little bit. And in other devices, they've actually gotten more aggressive, as of we've noted in May 15th of this year. And over on the right is from Blue's website, when it became public, they showed the devices that were affected. So ADUPS also has a command and control channel, and there's certain requirements for it to be activated. The device needs to be run for at least 20 days. After that, the device needs to have an uptime of 8 hours. And then once the connectivity change broadcast intent is received by their application, it will make a post request out to the following URL, fetch.do. And it will return a JSON object. And in that JSON object, if there's a string array containing any strings, it will execute them as the system user. Also, if you note the URL, it's over HTTP, which opens it up to man-in-the-middle attacks. So anybody who's on network or upstream and responds faster than ADUPS, they have remote command execution as the system user on your device. So here's a screenshot of man-in-the-middle proxy, the command and control channel actually being used. This is the only time we've actually seen it being used, and this was after it became known that they were exfiltrating user PII. And if you see the commands, they're essentially just downloading a new version of their app, installing it, and then starting it and zeroing out the application which they wrote to the SD card. So the PII exfiltration, looking at the application code, it's actually, according to the class names, are done under the guise of analytics. So there's a component named analytics receiver, and it's listening for certain events on the device, which are connectivity change and action power changed. And these should happen pretty often. Connectivity change is if you just leave or join a wireless network, this message will be sent. Action power connected is if you connect your device to charge, then the analytics receiver becomes active. Analytics receiver will start analytics service, which then creates an object called analytics report. To get to this point, the device uptime needs to be at least 10 minutes. And if it's been 72 hours since you first ran the device or since the previous exfiltration has happened, then it will gather PII and send it out to a server in China. And at the bottom, you can see some of the decompiled code. They're trying some basic obfuscation for a string called content://SMS. So instead of having the string literal in the code, they use a character array. So if you're just trying to grep through the code, you wouldn't see it. So here's the actual endpoint for the PII exfiltration. How they do it is they embed a zip file into the post request. You can see the zip magic number there. So in the zip file, they have various JSON files containing user PII and just information about the device. So when they were getting the text messages, which they're not anymore, based on a network response, they would actually encrypt the body of your text message. So if you did see this, you wouldn't actually see the body of your text message unless you had some knowledge of the application internals. Looking at the domain info, just seeing who registered the domain, using the dig command to get the IP address of the server, and then using GeoIP to get an somewhat approximate location of the server, which currently is in Guangdong, China. It used to be in Beijing. So here, the text message exfiltration is controlled by a network response. So ADUPS actually has the ability to target exactly what they're looking for, so they can look for specific text messages that involve a specific phone number or involve a specific keyword. So if they were interested in black hat, they could provide a keyword of black hat and get all the text messages. So up top is generally how they were doing it. They were just getting all the text messages. And kind of since it became known that they were doing this, they provided a phone number where it says given that's very long that shouldn't match, as well as a keyword that shouldn't match. So this is when they provide this network response, no text messages are exfiltrated. So here is from one of the JSON files showing an individual text message as a timestamp. The text in red is the actual encrypted body of the text message, and in green is the number. So in their application code, they have a hard-coded key and a des key, and the keying material that they use is called not crack. and the IV value is just the first 8 bytes, and at the bottom of the screen is just a simple Java class decrypting the ciphertext and obtaining the plain text, which is the body of your text message. Here in the zip file are some of the JSON files that can be present. Not all of these will be present. It just depends on the version of ADUPS software that you're running. Some of the most concerning are DC message key, which are the user's text messages with timestamps. DC mobile status can contain the cell tower ID. There's also DC tel message, which is going to be your call log and contain text message metadata. There's also DC browser history, which we discovered after November 2016 when it became public, which is just your browsing history. So we wanted to get an idea of the scope of the software that was exfiltrating PII, so we downloaded various firmwares, and we ran a tool on it which uses force path execution to look for any ADUPS applications in these firmwares that were accessing the text messages, and then from there we noted the JSON files that were present in the zip file, and these we didn't test dynamically. We used force path execution, which can break through constraints, so we're not actually 100% sure that exfiltration happens on these devices. So downloading the firmwares, we wanted to find out when these JSON files were introduced and how long it's been going on. So there's a DC tel message which contains the call log and text message metadata, and we noticed that this can happen in devices that run Android 4.4.2 up to Android 6. And we looked at in the system properties the build date to find when it was introduced, and DC tel message, the earliest we saw it was January 20th, 2015. DC message key, which is the user's text messages, we only noticed this in devices that were running Android 6. The earliest we saw this was May 15th or May 11th, 2016. There's also the JSON file that contains the user's browser history. This was first seen in June 30th, 2016. And one thing that we noticed that was a little curious was looking at the build fingerprint, which is supposed to uniquely ID or be a unique ID for a build. Some of the brand was called ADUPS, even though that wasn't the actual brand of the device. So DC browser his.json is a file that will contain your browsing history. And we noticed this on a Qbot X16S device. We noticed this in May. So this was after it was public that ADUPS was exfiltrating data. It was happening on this device. They were getting your browser history, call log, and unique device identifiers. And at bottom is a JSON array containing JSON objects, which will contain a timestamp, the actual title of the web page that you visited, the URL, as well as the number of times that you visited the website. Also, looking at the actual application code, we noticed that there were references to sales. So in some of the fully qualified method names, as well as a string constant. And at bottom, there's a URL, which is salesCountInterface.do. And we noticed this in a blue Grand M device, which we tested in May, and also a blue Life 1X2 device. And this, when it contacts this endpoint, it sends out the cell tower ID, mobile country code, mobile network code, IMEI, IMSI, MAC address, SIM serial number, and the phone number, and it encrypts them before it sends them to the web server in China. So that concludes ADUPS, and now I'm going to talk about an application called MTK Logger. So this application is present on Android devices that have a MediaTek chipset, and this application is usually for debugging or development purposes. It's not inherently malicious, but it is insecure and can be leveraged by any application that's co-located on the device to get PII about the user, which is written to the SD card, which any application in Android that has the read external storage permission can access the SD card. So the package name is com.mediatek.mtklogger, and this application cannot be disabled, so it's just sitting there running. You can remove the application if you've rooted your phone. And this is some of the data that you're able to obtain using this application. So there's the mobile log, which is the Android log, and the kernel log. The Android log is not available to third-party applications as of Android 4.1 because it can contain sensitive user data. There's the modem log, which you can see the AT command, so you're able to get the text messages, which are in 7-bit packed encoding. You can also see the AT commands for incoming and outgoing phone calls. You can also get a network log, which on these phones, they have a TCP dump binary in the system XBin directory. So once you're getting the network traffic, you can see any data that is not encrypted. There's also the GPS log, which is the latitude and longitude, as well as a timestamp, so you can kind of see where the user's been over time. So now I'm going to talk about the Xiaomi Redmi 4 device. We looked at this device and noticed that there were some vulnerabilities. So there's the Bluetooth snoop log, which on this device is active by default, which I've never seen on any other device. Usually to get the snoop log, you need to go into the settings application, enable developer options, and then specifically enable this capability. And so it's just on and writing to the SD card and essentially just a capture for the Bluetooth interface. You can obtain the modem log or turn on the modem log, which is written to the SD card, so you can get the text messages, call data. You can initiate a bug report, which is a dump of Android system services, which is in the system server process. And you can also get the Android log, which is not available to third-party applications. That's written to the SD card as well. You can capture a screenshot, which isn't transparent to the user. They will see that. So we contacted Xiaomi and told them about it about 2 months ago. They said they found it internally. But as of 3 days ago, the device didn't have a firmware update to fix these issues. So this application is meant for development and debugging purposes. The application has an unprotected broadcast receiver, which any application on the device can just send it a message to activate it. And if you send it a broadcast intent with that action shown, it will initiate a bug report, which makes the device vibrate 3 times. And then once it's finished generating the bug report, it will vibrate 3 times again and then leave a non-sticky notification. This could be done while the user isn't using the device, which you can tell by listening for certain broadcast intents. And then you could use a denial of service attack to soft reboot the phone to get rid of the notification. So in the bug report, any active notifications that haven't been swiped away by the user will be present in the bug report. So at bottom is just a text message that was received showing the number and the body of the text message. In that same application, they have another unprotected broadcast receiver called Modem Log Generator. It's listening for Android secret codes. So if you send it the secret code that it's looking for, it will activate the modem log. This creates a sticky notification that the user can see, but this application that is generating the modem log can't be disabled. So even if they disable it, you can just enable it again. You can obtain the text messages, which are in 7-bit packed encoding, as well as a call log, and this is written to the SD card, which can be accessible to third-party applications. And just below is the code to send the broadcast intent. And to wrap it up, so a lot of people spend time looking at external threats, repackaged applications, websites. And I've provided a few examples that you should also pay attention to the code or in the application's processes that come shipped on the device because they can be malicious or insecure. And if you're concerned about ADUPS exfiltration, I've provided some of the domains there. So if you want to block those, you might want to do that. And ADUPS has, since it became public in November of 2016, they've certainly scaled it back on some devices, and it seems that they've gotten, somewhat more aggressive on others. And in certain times, they will actually use their command and control channel to replace their exfiltrating app with one that doesn't exfiltrate data. Thank you. Does anybody have any questions? They're on the system partition. Yeah. And you can tell when they've, if they update the app, you can see that application will be on the data partition. And then the package names are com.adups.foda and com.adups.foda.syshopper. If you see either of those on the data partition, then they've updated them. And if they've done that, there's probably a good chance that there was a reason for them to do that. And you can just uninstall that and then pull the ones off the system partition and disassemble them and see the code. And also, they've introduced certificate pinning to make analysis more difficult, but you can just root the phone and use exposed or an exposed module to defeat SSL pinning to actually see the traffic. Any other questions?
So I don't know, I came in a little late. These ADUPS only show up on phones or Android devices?
It's usually, they're on different phones. Usually they tend to be on lower end phones. I have these are some of the device manufacturers or OEMs where it's present, and it's actually present on a lot more because not all ADUPS software will actually exfiltrate much PII. I mean, this is focused on the ones where they're getting kind of, somewhat egregious amount of PII.
Question over here. How much of the implementation of what they did was Java versus native?
It was pretty much all Java. I mean, if they would have put it in native code, it would have been more difficult. But you can just disassemble the Java or decompile it, and it's pretty straightforward once it's at that level.
So during your research, did you get any insight as to why they're doing this?
I can't really speculate on why, but you can see the data that they're getting, and it may have some value. So I don't know what they did with it once it hit their servers in China. Say that again? I don't know that for sure, but that's where I've seen it. So I'm not making the claim that it couldn't be in a high-end phone, but that's the only, at least, where I've seen it. So I haven't seen it in a high-end phone yet. I mean, I think some of the high-end phones, they may try and do the photo process themselves, or rely on a company that doesn't have, known to have issues, either security issues or exfiltration issues. You could certainly run an AV on the device, and you could check for known threats, and it would be a good idea to do that. I mean, you could, if they're so inclined, they could disassemble the programs and check themselves, but I would definitely recommend using an AV and scanning for applications that are known to be malicious. You won't get anything that's unknown, but at least you'll get what's known. No, these are all unofficial outside, come pre-installed on the device, and the only time I've seen them been updated is when using their command and control channel or just one of their network endpoints to update their apps themselves.
Thank you, everybody. That's all the current time we have for questions. If there are any additional questions, we're actually going to move the party over to South Seas H, which is just around the corner. Thank you and have a great day.